Good day, my amiable viewers. My name still remains Israel. You are welcome back to class. In our today's discussion, we are going to be concentrating on the forthcoming Neco exams, since we already finished chemistry in WAEC. So, without wasting time, let's have a look at some questions. Remember, these questions are carefully selected, just like we selected some in our just completed WAEC chemistry theory and objective, and many of them featured in the exam. So look at it. Selected questions for Neco objectives. The common features of reactions at the anode is that these are objective questions. Subsequent videos will also be talking about theory, which you may likely encounter. Now look at it. He said the common features of reactions at the anode is that electrons are consumed, ions are reduced, oxidation is involved, the electrode is dissolved. Before we can answer this question, let us have a look at certain reactions that occur at the anode and cathode. Let's take a typical example. Let's assume we are using electrolysis of concentrated sodium chloride solution. Even if it is diluted, it's the same principle. So, electrolysis of concentrated sodium chloride solution. You see sodium chloride aqueous. This one gives you Na plus Cl minus. This is what will happen. Remember, because it's in aqueous form, the water in which it is dissolved will also ionize. In which case, let's write it properly. This is aqueous. You have H2O to give you H plus OH minus. So, because we have so many ions, different ions present, there is now going to be competition as to which will migrate to the cathode. But all of them will migrate to the cathode as to which one will be discharged at the cathode and at the anode respectively. Remember, they are all inside the solutions. So you see these negative ions will migrate to the anode because the anode is deficient in electrons. So you need to take electrons from these negative charge ions and neutralize out. While this one migrates to the cathode. Remember, the cathode is already rich in electrons. So because we are concentrating, remember again, sodium has positive charge, but it is very, very reactive, extremely reactive, and on top of among the very high metals on top of the activity series. Therefore, it cannot be discharged because of this high electropositive nature. But we are not concentrating on the anode. Remember what the question says. The common feature of reactions are the anode, not the cathode. So we just ignore this. So at the anode, you have, because it is concentrated, we are going to use chloride ion because the concentration of the ions is enough. This one is too little because we are dealing with concentrated solutions. So the chloride ion is sufficient. So we now use now becomes Cl minus to discharge. We release the electron Cl plus electron. So let's write it on top. Because of the high concentration, so chloride ions will be discharged. So we have Cl minus to give you Cl plus electron. You know this one will also combine with another Cl. Cl, because it's happening thousands and thousands of times inside the solution, plus Cl to give you Cl2. In which case, we can summarize it by saying 2Cl minus to give you Cl2 plus 2 electron. This is a summarized form of it. Now, what actually happens, what we are interested in? You can see that this, in terms of oxidation number, is -1. While this one, in terms of oxidation number, is 0. So from -1 to 0 is increase in oxidation number, meaning oxidation has taken place. So that is the only explanation we can give here. So you look at the option, the common features of reactions at the anode is that A, electrons are consumed, no. Instead, electrons are released. B, ions are reduced, no. Ions are increased. Because this one is negative charge. It has increased to 0. From your number line, mathematics, from -1 to 0 is an increase. The other one is oxidation is involved. That is the answer. The answer to this is oxidation is involved. Electrons are dissolved. No. So please listen to this explanation very well. Because most of your past questions, you may not see this kind of explanation in it. So you listen very well and properly understand it. So the answer to this is C. Answer equals C. Then look at the second question. Consider the following reaction equation: 2NO plus O2 to give 2NO2. What is the change in the oxidation number of nitrogen? That one is not tedious, shouldn't pose a problem for you. However, you have to really follow the processes so that you understand it. And when you are in the hall, it becomes very easy for you. Let's write the equation out. 2NO plus O2 to give you 2NO2. Okay, this is nitrogen 2 oxide, oxygen, nitrogen 4 oxide. But how do we know? Let's calculate the oxidation number. You look at this, this is minus 2. So in which case, this automatically becomes plus 2. So nitrogen again here, this minus 2. You call this S. Ignore this 2, it's not necessary because you cancel out at the end of the day. S plus minus 2 times 2 equals 0. X minus 4 equals 0. S equals plus 4. Automatically, it means this nitrogen is plus 4. So the change in oxidation number is plus 2 to plus 4. So making the answer, let's look at it. A is plus 2 to 0, plus 2 to minus 2, plus 2 to 4. So the answer to this is C. Answer equals C. Answer equals C. So that is how that one goes. Then let's have a look at the third question. I hope you are following. If you have any issues with it, please signify by writing it in the comment section to be answered immediately. Which of the following is which? Which of the following statements is not a chemical statement? Is not a chemical property of an acid? Let's see the first one. Evolution of ammonia gas when heated with ammonium salt. That one is not a property of an acid. Evolution of ammonia gas when heated with ammonium salt. Remember, acid react with base to form salt and water only. So that's not a property. But let's have a look at the rest. To evolve ammonia gas, you have to heat the ammonium salt with a strong alkaline solution such as sodium hydroxide. That's the only possibility where ammonia gas will be released, not from acid. Then the B1, evolution of carbon 4 oxide gas when added to triazocarbonate 4. When you react carbon 4 oxide, when you react acid to triazocarbonate 4, it will release carbon 4 oxide gas, which usually turn like water making. Look at the typical example. HCl, this is an acid plus Na2CO3. This gives you 2HCl actually. 2NaCl plus H2O plus CO2. Please remember, because of your forthcoming Neco, there are issues here you need to tackle, you need to really understand. This is, I will discuss it in one of my videos before your Neco exam so that you really understand it properly. That is not actually, even though you are very intelligent, may not be able to make up to that grade you are hoping for yourself, except you follow these precautions so that when all these errors are removed, that grade you hope for yourself, you're able to attain it. For example, you are given an equation and the space is not enough here. On no ground, on no condition must you carry it to this side. If instead be writing it here, let it be long, continue to write it down, or continue to write it up. Don't ever cross this sign, because if you cross it, you mark the equation wrong. It means you don't understand the principle of chemistry as regarding balancing of chemical equation or writing chemical equation or the stoichiometry. In balancing of chemical equation or writing chemical equation, you must know that reactants are always written on the left hand side, while products are written on the right hand side, and both of them are demarcated by the presence of this arrow. This arrowhead point to the product and the back point to the reactant. So by the time you shift it to this side, it means your equation is no more valid. you have carried the product to the left hand side, and it's only reactants that are permitted to be written in the left hand side. Please don't forget that. So you see this, it produces sodium chloride plus carbon dioxide plus water. So you see it. So this option B, evolution of carbon dioxide gas when added to it's not acceptable. Formation of salt and water only. We already know now when acid react with a base, produce salt and water only, or salt and water with alkalis. For example, you have HCl plus NaOH to give you NaCl plus H2O, salt and water. So that one is also not acceptable. Formation of salt and hydrogen gas with reactive metals. That one is not also acceptable, because if you react with reactive metal like zinc, let's assume you are using HCl or H2S, any of them. Let's use HCl, a common reactant, plus Zn. It gives you ZnCl2 plus H2. Just balance it here. So you see it produces salt and hydrogen gas, meaning that the only one that is accepted is option A, evolution of ammonium gas. So the answer here is option A, answer A. Then the last one, last but not the least, number 4, 0.2 gram of salt is required to saturate 200 cm³ of water at room temperature. What is the solubility of the salt? So in this kind of situation, there are several methods you can use, but I've actually coined out a very short method that is applicable and you still score your maximum mark. So the formula, if you check my previous video, you will see it. So the formula for calculating, so you just go to solubility calculations in my previous video, you see it. But within with time, I'll see if I can include the one of graph. So you see it, when you have this, you have 0.2, you say solute equals 0.2 gram. It says so it's required to saturate this. So solvent equals 200 cm³. Now remember, a solute is a substance that is capable of dissolving in a solvent to form a solution, while a solvent is a medium that is capable of dissolving a solute to form a solution. Then a solution is a complete, perfect, homogeneous mixture of a solute and a solvent. And again, they say saturated solution. A saturated solution is a solution that contains the maximum amount of the solute it can dissolve at that particular temperature. If you increase the temperature, more will dissolve. But so long as you retain that particular temperature, the maximum amount it can dissolve is the saturated solution. How do you identify saturated solution? You put a little quantity, after putting and putting, is dissolving it. A time will come when you put a very small quantity, it will dissolve when you stir it, but after some time start returning back. If you stir it again, it will dissolve. Remember, temperature must be constant. If you allow it to settle, it will come back again. So that particular point is when you know it's a saturated solution. It always contains small quantity of the thing lying by the side. So that is a saturated solution. So to calculate, say what is the solubility? A very short method you can do, especially because of your objective. You say solute over solvent times 1000 over 1. Remember, we are calculating gram per, you see the unit of the answers, gram per dm³. Solute here is 0.2. 0.2 over 200 times 1000 over 1 over 200. 200 here 1, 200 here 5. 5 times this one gives you 1.0 gram per dm³. Let's see. So B, answer equals B. Option B is the answer. So this is all we can take for today's video. Please don't forget, kindly subscribe if you have not subscribed before. And if you have subscribed before, kindly share to your friends. It's not wise only you making A's while your friends are still struggling. Thank you very much and God bless you.